So within the traditional model, after waterfall model, let's cover the V model, or we also call it as validation and verification model. The V model, also known as the validation and verification model, is a software development process that emphasizes the relationship between development stages and testing activities. It is an extension of the waterfall model where each development phase has a corresponding testing phase, visually represented in a V shape. So this is the key here. Each development phase has a corresponding testing phase. Now we have seen that waterfall model has one disadvantage, that 100% test development is complete, then only the testing will start, right? So let's see how V model will help here. Let's see the key features of the V model. Verification and validation. The model distinguishes between verification, building the product right, and validation, building the right product, ensuring that each aspect of the software is checked and confirmed. Early testing. Testing activities are planned alongside development, allowing for early detection of defects and ensuring that each phase meets its requirement before moving to the next. Clear structure. The model provides a structured approach with clear defined phases, making it easier to manage and track progress. Now let's understand with this pictorial format. So what it says, and that's why it's called V model, because if we see, for every phase of the development there is corresponding a testing phase. So for example, requirement design, we have the acceptance test. For system design, we have the system test. For architecture design, we have integration test, and so on, right? So that's why, because it looks like we can imagine it as a V, that's why it is called V model. Let's see the phases of V model. So likewise, we have waterfall model. It is just extended version of waterfall model. We have the same phases. Likewise, we have the requirement analysis, system design, architecture design, the module design, etc. I mean, whatever we have covered, it gives some extra stress on the validation, on the testing phase. So for each development phase, there is a corresponding testing phase. So requirement analysis, it defines user needs and system requirements, right? And the validation would be to ensure requirements are complete and clear. System design will outline the high level architecture of the system, and validation will check design alignment with the requirements. Architectural design details the system's structure and component interaction, and in the verification, it will confirm that the architecture can support requirements. Then the module design will break down the architecture into individual components, and then the verification phase will ensure that the designs for each modules are correct and feasible. Then goes to implementation phase, actual development of the code, and then the validation phase will start from here, right? It involves unit testing, implementation phase, corresponding unit testing for individual modules. Then we have integration testing. So test interaction between integrated modules. If there are multiple systems we are integrating with, so validation of those integrations, if they are working together or not. Then we have system testing. It validates the complete system against requirements, and validation will check if the system meets user needs and business objectives. Then we have the acceptance testing, final validation by business users and users before deployment, and the validation phase will confirm that the user is ready, the system is ready for production or not. Now let's understand when to use the V model. When should we use, which use cases are appropriate for V model? Okay, well-defined requirements. The V model works best when the project has clear, stable, and well-documented requirements from the outset. So if requirements are likely to change frequently, a more flexible model like Agile may be preferable. Right? So if the requirements are fixed, very well defined, then V model can be considered. Regulatory and compliance projects that must adhere to strict regulatory standards. For example, healthcare industry, finance industry, aviation industry, right? Because there we need that every phase has done the correct job. We need revalidation of each phase, right? So that is a good example where we should use it. And it benefits from the view model structured approach to validation and verification. The documentation and traceability aspects are crucial in these scenarios. I mean, the healthcare industry, finance industry, or aviation industry, or legal, something related to legal. Smaller to medium sized projects. The V model is often most effective for smaller to medium sized projects where the complexity and scope are manageable. In larger projects, a more iterative approach might be required to handle evolving requirements. Consider we have a small project, so it is easy to even foresee what will be the requirement. The requirements can be freezed, requirements can be understood, well understood, right? But if we are building the solution for enterprise where it's a huge enterprise, the solution is huge, there are lots of requirements, it is very difficult to have well documented requirements in the start of the project. Next would be stable technology and environment. If the technology stack and project environments are stable, the V model can be very effective. In rapidly changing environments, more adaptive methodologies may be necessary. Again, agile. Projects with well-defined testing strategies. The V model is ideal when there is a clear strategy for testing at every phase of development. Teams should be prepared to develop comprehensive test plans and have the resources to execute them. And the last one would be clear project timelines and milestones. The V model is suitable for projects with defined timelines and milestones where deliverables are clearly outlined. This model helps keep the project on track by emphasizing the completion of each phase before moving on. So these are the use cases where we can consider V model as the SDLC model. Now let's see the advantages of V model. First one is clarity and structure. The model's structured approach allow for easy tracking of progress and understanding of relationship between development and testing. Early defect detection, like I said, because for every development phase we have a corresponding testing phase, so early defect detection will help. Testing is integrated into each development phase, enabling early identification and resolution of defects. Improved quality, of course, because for each phase we will have corresponding testing phase, so the quality will eventually improve. With the rigorous validation and verification processes, the model enhances the overall quality of the software. Let's understand the disadvantages of V model now. So first one is it's rigid in nature. Likewise, in waterfall model we cannot go back. The first phase is complete, then only we will move forward. In this phase also, the development phases are having corresponding testing phase, but we cannot go back to fix anything, right? The V model is less flexible than agile methodologies, making it difficult to accommodate changes once development begins. Assumes requirement stability. The model assumes that requirements are well defined and stable from the outset, which may not always be the case. 99% case requirement changes. So it is very difficult to have static fixed requirements and then on top of that we start working. So that's why this is one of the disadvantage of this model. High upfront planning. Significant time and effort are required for planning and design phases, which may delay the start of actual development. So let's conclude in this. The V model is an effective approach for projects where requirements are clear and stable. This is the key term. So if requirements are clear, not changeable, not changing, it's stable, then it can be considered. Its emphasis on validation and verification at each stage ensures high quality software, making it suitable for safety critical systems where thorough testing is essential. And the examples I had given is life science related project, healthcare related project, aviation related projects, right?